Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Because we know that algorithms are super cool achievements, but y'all, they're terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems could be developing.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Dum-dum.
Hey, I'm just going to tell you what happened.
Oh, no. What happened?
You pushed the button to record.
I know, to record,
and
sorry.
No, it's okay. And I started to tell you because I didn't realize you had pushed the button. My phone is on Do Not Disturb, but texts are getting through. So then I go,
weird.
What's happening? What's going on?
Oh, it's your latest update. Remember you told me that you did the latest update and you're not happy?
Don't do it. Don't do it.
Yeah, well, so I got the opportunity and I was like, nope. Kim said don't. So
I mean, you're going to have to at some point, but
I know. But
not a
yet.
fan. All right.
I like to let it come out and then let everybody work out all the bugs. And then once the bugs are worked out, then I'll dive in.
Good plan.
Okay,
good
cool.
plan. All right. So, hey, we have had quite a few episodes where we haven't done a lot of math. Let's do some math today.
What?
I know.
Yeah, it's one of our favorite things to do is doing some math. All right, cool. So, Kim, I have some math prepared for us to do today. Are you ready?
Okay.
Okay.
Sure.
The way we're going to do this is I'm just going to sort of set the stage. So rather than saying, hey, Kim, what are you thinking about? I'm going to kind of do it. Kim, can you be like a sixth grade kid? Kind of channel.
I'll try.
Channel sixth grade,
Okay.
which means we've got kids that have lots of different backgrounds in that sixth grade class. But I'm going to kind of try to facilitate this string like I would with a sixth grade class. So I'm going to,
Okay.
I think it'll become clear as we go. All right.
Okay.
Here's the first
That
problem.
sounds good. Mm-hmm.
Okay, everybody, we got $14. So
Okay.
picture $14. Yay, $14. Not a lot of money. I know. We can go buy lunch, right? $14.
Mm-hmm.
Though lunch is getting more expensive. Anyway,
It is.
okay, we got $14. It's extra from whatever we were just doing. We got $14 extra, and there's 8 of us. And so this extra $14, we're going to split it among the 8 of us.
Mm-hmm.
I know it's not a lot of money, but $14 split among the 8 of us. Go ahead and solve that, everybody. Everybody thinking, how much money would each of us get if we shared that $14 fairly among 8? Now, I'm going to let kids think a little bit. I might circle, might see what's going on. But I am going to then say, maybe if I found it, I might call on a kid. But I'm going to say, did anybody think about, we got 8 people, $14. Well, maybe I should say, so if you're listening to the podcast, maybe pause for a second and think about that. How much money would each of the 8 kids get if $14 was shared evenly? I'm going to look and I'm going to say, did anybody give everybody $1? So Kim, let's say your eyebrows raise or you've got your thumb up or whatever. Could you be a kid who said, well, yeah, I can think about $14 shared among 8 kids by kicking it off, giving everybody $1. What? Say more.
Yeah. So each kid gets $1, or each person gets $1, and that would be 8 of the dollars.
Okay. So I'm going to, sorry, can I pause you for a second?
Yeah, sure.
Because I'm writing as you're saying that.
Okay.
So as the student's saying that, well, maybe I'll listen to you first. Maybe I should listen. That just occurred to me that a better teacher move would be to listen to you first. So go ahead.
Okay. So I have $6 left.
Okay.
So I'm going to then give 50 cents to everybody, and that uses up 4 of the dollars.
See, I really do think I would be writing on the board at this point.
Okay.
I think.
You could write it on the board.
Okay. So I think I would have written $8, fraction bar 8. When you said we're giving everybody $1, I would have said, so these 8, you gave $8 to 8 people. And then under that, I would write $1.
That's
So
exactly what I have.
$8 divided by 8 and $1. And then you said there was $6 left.
Yeah. And so
And what
for
did you do
4
with
of
the
the
$6?
dollars,
Four
4
of
of
the
the dollars I gave to 50 cents to each person. And that's $4 for 8 people.
So now I've written $4, fraction bar 8.
Mm-hmm.
And you're saying that's 50 cents. Now here, we're going to pause for a second. I'm going to say, is that 50 cents, everybody? I'm going to look around. I'm going to call on somebody else. How do you know that $4 shared among 8 people is 50 cents? So Kim, I don't know. What would it be a justification of yours for that?
So $1 would cover 2 people. It's 50 cents and 50 cents.
Mm-hmm.
So each of the dollars would be for 2 people. So $4 would be 8 people.
Nice. I could also imagine a kid saying, well, if $8 shared among 8 people was $1, now we have half the amount of money. shared among the same number of people. So they would get half the amount of money. So they had the dollar before, now they have 50 cents. For. Do you have anything else you can think of? Just because never stop with only what you can think of.
Yeah.
Cool. Okay, so far you have $8 shared among 8 people, $4 shared among 8 people, but we needed a whole $14.
That's only $12. So then I have $2 left among 8 people, and that's a quarter for each person.
And how do you know that $2 shared among 8 people is a quarter?
You just said that $4 for each person would be 50 cents. So $2 would be half as much.
Nice. Then I might stand back and look at what I have on the board. So right now I have $8 fraction bar 8 plus $4 fraction bar 8 plus $2 fraction bar 8. And I might say, do those look like fractions? So underneath that, I have $1 plus 50 cents plus 25 cents. But I'm kind of curious if anybody goes, oh yeah, 8 divided by 8 is 1, and 4 divided by 8 is 1/2, and 2 divided by 8 is 1/4. And those fractions are equivalent to that 1 and that 50 cents and that 25 cents. Something, I might try to pull that out. And so how much money did each kid get if we were sharing the $14 among 8 kids? $1.75. $1.75, because we add those up, you get $1.75. And just for fun, Kim, what would that fraction be if we wrote that as a mixed number or an improper fraction? Either one.
You could write 1 3/4.
Okay. And the improper fraction?
14/8.
Ah, hey, there's our original 14/8. Nice. Could you also have fourths?
Yeah. You could have 7/4.
And you could have 7/4. That might have been a fail on my part right there. Pretend I didn't ask that. Pretend I didn't. Let's stay at the 1 3/4.
I wanted to call it 14/8.
You did, didn't you?
I did.
I'm going to stay at the 1 3/4. So
Okay.
far on the board, I've got 1.75 or $1.75 and 1 3/4. Okay. Next problem. So see, teachers fail every once in a while. You just sort of smooth it over. Kim knows where I'm going. This is why she's cracking up at me. Okay. So great. First problem. Second problem. This time $7. This time shared among 4 people. $7 shared among 4 people. So new problem. Okay. $7, got the extra $7, but this time we only have 4 people. So $7 shared among 4 people. I'm going to let people work. Kids are working. 6th graders are working. I'm looking around. By the way, I could be doing this in 5th grade. Maybe even 4th. And for sure up. But I'm thinking 6th grade because I think it'll help everybody kind of whatever. Okay, so $7 shared among 4 people. I'm going to do the same kind of looking I did before, and I'm going to ask the same question. Did anybody give everybody $1? Anybody start with, and let's say it was Kim is the kid who I called on before. I'll probably say, did anybody use Kim's strategy of giving everybody $1? Whoever that was, that kid I called on for the $1. So Kim, can you run with that? What would it look like if a kid had given everybody $1?
Yeah, so each kid is going to get $1. That's 4 of the $7.
Okay.
And then I have $3 left. So I have $3 for 4 kids. Honestly, if I'm a 6th grader, I might go the same $2 shared among those 4 people is 50 cents again. And then I have one more $1, and that's a quarter for everyone. So I'd have $1 and 50 cents and 25 cents.
So let me just tell you what I wrote while you were talking. And I would probably say, whoa, that was fantastic. Good strategy. Say it again while I represent it on the board. And so when you said $4 shared among 4 people, I wrote $4 fraction bar 4. And you said that's because everybody gets $1. So underneath that, I wrote $1. And then you said $3 shared among 4 people. And you said, but if I was a 6th grader, I probably thought about that as. So I actually wrote $3 shared among 4 people, $3 fraction bar 4. And then when you said, but I'd probably break that up, then I erased it and I wrote $2 fraction bar 4. So $2 shared among 4 people. And you said that was 50 cents. And could you, how are you reasoning about $2 shared among 4 people? How do you know that's 50 cents?
We just said it was 50 cents in the previous problem.
$2 shared among 4 people?
Oh, no, sorry. We just said the $4 for 4 people was $1. And the $2 would be half as much.
Half as much. Because it's, nice. And then I might ask at that point, did anybody look at it like it as a fraction, kind of like we did above? And somebody might say, oh, yeah, 2/4. That's like a half or 0.5. And then you said you had $1 left over. So I have $1 fraction bar 4, which looks like 1/4. But we might also want to reason, if $2 divided among 4 people was 50 cents, then half the amount of money, $1 shared among the same number of people would be half the amount of money. So not 50 cents, but would be 25 cents. Cool. And then what is $1 plus 50 cents plus 25 cents?
$1.75.
Hey, and then I'm looking to see if anybody's smiling. And Kim, I know you are. I might say, why are you smiling? And do you want to read my mind? Why do you think I'm... Yeah, go ahead.
Yeah, because each person gets the same amount of money as last time. And so,
last time... Keep going.
Last time there were $14 for 8 people. And this time there's $7 for 4 people. And in both those cases, each individual person gets $1.75.
Interesting. So then we might go back and look at that $14 shared among 8 people as a fraction, and look at the $7 shared among 4 people as a fraction. And is 14/8 how does 14/8 compare to 7/4? Oh yeah, they're equivalent. Cool. So we sort of scale down the numerator, scale down the denominator, sort of cut both of them in half. But we could also look at it in the fair sharing context. I had $14 shared among 8 people. I cut the money in half. Now we only have $7, but I also cut the number of people in half. Is that
not literally though? Not literally.
You don't want to cut the people. I cut the number of people in half. Is that better?
Yeah, there you go.
Okay, cut the number of people in half. That was a good catch. So if we have half as much money shared among half as many people, will they get the same amount of money?
Yeah.
That's interesting. And we could sort of talk about that. And we could, I think that would be a good thing. That's really good relational reasoning that we want to kind of help building kids. Okay.
And I can imagine that now is when you'd put 7/4 next to your 14/8.
Well said.
We're talking about doing before.
Yeah. And so up above where I said, oops, I forgot, I didn't mean to ask for 7/4. Exactly that. When we had that 1 3/4 for the $1.75, that is 7/4, which is then kind of that sort of next problem. Yeah, nicely done. Cool. Okay, so then I would give, so those are the first 2 problems in the string. Third problem in the string. How about this time we have 12 extra dollars, $12 hanging around, and we have to share with those eight kids, those original 8 kids. So we've got $12 shared among 8 kids. Now I'm really curious what kids are doing. Walking around, looking at what they're doing. I'm going to try to pull out a couple of different ways of thinking. Did anybody do the let's give everybody $1 strategy? So Kim, will you just be the kid that give everybody $1?
Yep. Everybody gets $1, and that's 8 of the dollars.
So $8 divided by 8, that's $1. Okay.
And then we have $4 left to share among 8 people. And we said that was 50 cents.
We've already done $4 divided by 8 people. Yeah, up above, and I could circle that above where we've got that written. You're like, that's 50 cents. And then, but Kim, shouldn't they have gotten the same amount of money as the other 2 problems? No, it's a whole new problem.
Yeah.
So I might make that joke, like, did we goof? They should be getting the same amount of money.
But it would be really great if a 6th grader says, I'm going to go back and use the portion of the $14 where we broke it up from $8 and $4. Yeah.
Because, and if you guys could see my paper right now, we had $8 divided by 8 and $4 divided by 8. And then we had $2 divided by 8 in the 14 divided by 8. But in that problem, we exactly had the 12 divided by 8. So we sort of pull that out. Nice. Trying to think if I would go anywhere else. I'd probably encourage kids to just look at fractions. I might have had kids. No, that's probably good there. Okay. So then in this case, we got $1 and we have 50 cents. So each kid gets $1.50. I'm thinking. Yeah, that's probably good for that one. Then I might say, okay, next problem. What if this time we only have 3 extra dollars? But that's okay because we're only going to share it with 2 kids. So there's 2 kids. They're going to share fairly. They're going to share fairly $3. 2 kids sharing $3. Why are you laughing?
If I'm in a 6th grade class, everybody right now is like, "That's me. I'm getting the 2. I'm the 2. I'm
one of the 2. I'm one of the 2. Give me the money. I want the money."
Absolutely.
And at this point, I might be like, okay, only 2 kids. You're going to get more money, right? Nice. There's only 2 kids. Or are you? Did anybody do the give everybody $1 strategy? So Kim, let's do that one first. Let's give everybody $1. Okay.
Yeah. Everybody gets $1, and then there's $1 left to share among the 2. So they get 50 cents.
All right. So I wrote down $2 divided by 2 is $1. And then there's $1 left over divided by 2. Oh, and $1 divided by 2, that's 50 cents. So that is, and that is like the one that we had, that was like the $12 divided among 8. And so now I'm going to look, is there a relationship between the 12 divided by 8 and the 3 divided by 2? I'm going to pause. And then, Kim, what relationship do you see among the between the $12 divided by 8 and the $3 divided on 2 students?
Yeah, each pair of students gets the same amount. So in the 3 divided by 2, they get $1.50, but also the 12 divided by 8, they get $1.50 because you have a fourth as much money and a fourth of the number of kids. Like
nice. Like 12 divided by 4, $12 divided by 4 is $3.
8.
Sorry?
Wait, 12 divided... Oh, sorry.
$12 divided by 4 is $3.
Yep.
And 8 kids divided by 4 is 2 kids. And so the problems are equivalent. So, hey, it's interesting. Of the 4 problems that we've just done, we have 2 sets of equivalent problems. 14 eighths was equivalent to 7 fourths, and 12 eighths is equivalent to 3 halves. And so that's interesting. I wonder, looking back, if you ever ran into 14 eighths, if you'd prefer to just solve 7 fourths. Like find 7 divided by 4 rather than finding 14 divided by 8. Could you? Like you could choose at this point. You could say, hey, I could just scale up the numerator and denominator, or I could scale down the numerator and denominator. As long as I had an equivalent problem, I could choose the one that I wanted to solve. In both of these cases, from the 14 divided by 8 and the $7 divided among 4 kids, we scaled the 14 down to 7 and the number of 8 kids down to 4 kids. And the $12 shared among 8 to $3 shared among 2, we scaled down both of those. I wonder if there'd ever be a time when you might want to scale up. I don't, probably not. That'd be weird. Next problem. How about this time I'm not really actually going to do money so much. I'm just going to say that I've got 5 1/4, so 5 1/4, divided by, and I'm writing that on the board like a compound fraction. So I've got 5 1/4 fraction bar underneath it. 5 1/4 fraction bar 1/2. So 5 1/4 divided by 1/2. Let me just say it again because it's all not visual. I've got 5 1/4, 1/4, big fraction bar underneath it, and then 1/2. So compound fraction. All right. What's your gut urge, Kim?
I want the denominator to be 1. So I'm going to scale up times 2.
Because 1/2 times 2 is 1.
And then I'll have 1 in the denominator. So I'm going to double the 5 1/4 and make that 10 1/2. So my new problem I have is 10 1/2 divided by 1, which is 10 1/2.
So there might be a time when you just want to scale up both the numerator and the denominator to find an equivalent problem that's just divided by 1. Well, that seemed really helpful.
Yeah.
Like, wow, 5 1/4 times 2, that's not too bad. It's 10 1/2. 1/2 times 2, double that. That's just 1. Nice. Last problem of the string. What if I gave you a problem like 3 1/5, all divided by, so big fraction bar, 1/3? What are you thinking about? Well, actually, so pause. Podcast listeners, pause. Might you want to scale down, scale up, both the numerator and the denominator, find an equivalent ratio, equivalent fraction that might, I don't know, be easier to solve? All right, Kim, what do you got?
So I'm looking at the third in the denominator, and I'm wishing that it was also 1. Okay. So I'm going to scale up times 3. So I've written times 3. So 3 1/5 times 3 is 9 3/5. And a third times 3 is 1. So I have 9 3/5 divided by 1. So 9 3/5.
You're saying 3 1/5 divided by 1/3 is 9 3/5. Bam. Because 9 3/5 divided by 1 is equivalent to our original problem, 3 1/5 divided by 1/3. And you just you would rather, if I gave you the choice, you'd rather solve 9 3/5 divided by 1 than 3 1/5 divided by 1/3.
Oh, sure. Yeah.
And we could look back just a little bit. When I gave you 5 1/4 divided by 1/2, we could have asked how many 1/2s are in 5 1/4. We could make sense of that. Like, how many 1/2s are in 5? Is that 10? We have 10 1/2s in 5. But then we'd have to ask how many 1/2s are in 1/4. Well, that's not too bad. How many 1/2s are in 4th? Well, I think there's only a half. There's only a half of a half in a 4th. And we would get our same 10 1/2. So that's a quotative look. How many 1/2s are in 5 1/4? And we could do that. We could also do the partitive look that you took by finding an equivalent fraction, equivalent ratio that was easier to sort of think about 10 and a half divided by 1.
Yeah.
But in the second problem I gave you, 3 1/5 divided by 1/3, it's a little more difficult to think about how many 1/3s are in 3 and 1/5. We could, but for this problem, I think I would just rather scale up like you did, triple both of them, get 9 3/5 divided by 1. Bam, that's just 9 3/5. Y'all, there's some fraction fun on this podcast day. Hope you enjoyed that one. What do you think, Kim?
I love this strategy, and I think we get a lot of questions about fractions and division, and a lot of people asking, how can I help my students make sense of fractions? And I think often we leave out this partitive meaning, and there's so much power and so much value in helping students understand both quotative and partitive meaning of division with fractions.
And notice that while we got there with this string, we also did a lot of equivalent fractions above. We did a lot of reasoning about division and fair sharing. We did a lot of connection between fractions and decimals. Like it's about developing mathematical reasoning. It's not just getting, because somebody could be like, Pam, for all those problems, we could have just like invert and multiply. Like you could have just done long division algorithm for the first bit, like it could have been far, quote unquote, easier for us to solve those problems. But notice how we use these problems to develop reasoning, not just for kids to get answers.
Yeah.
Cool. Thanks for having fun doing some math today.
Yeah, for sure. It's our favorite.
All right, y'all. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.